Hey everybody, this is Larry. This is Biweekly Contest 151. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, these forums, everything in between. This is a live recording of the virtual contest. TLDR, I did not wake up early enough, so I just kind of slept in. Yeah, my body's been feeling a little beat up lately just because of the injuries and all these things. But anyway, yeah, so I think that's basically the. Oh, let me fix out my notebook, okay. And yeah, this is the virtual contest. Not much of an explanations, but definitely just hopefully this is helpful. And yeah, for if you do want explanations, each problem will have its own video, so definitely check that out. But yeah, I think let's get started. Yeah, okay. Scroll down slowly. That was too fast. Okay. All right, am I ready? Let's go. 5, 4, 3, 2, 1. Go, 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 go. Ooh. What? That is silly, but okay. Something like that. Right? I mean, I could have misread it. That was too fast, honestly. But Copies 5 minus copy minus 1. Say what? Number of possible arrays copies such that, okay, so you have the original array, you have copies, and the deltas are the same, but the bounds are, okay. Everything's just determined by the first number, right? Okay, let's see. So we can't do a for loop for the bounds. It's just binary search on the bounds, right? No, that's not true. Because some can go too high, some can go too low. So I don't think that's binary search. Just carry the bounds forward, right? So okay, so upper, lower for each one, and then that's it, right? Okay, fine. How do I want to write it though? I mean, the original even doesn't even matter. Yeah, this is so annoying to write, maybe. I don't know, try to figure it out in my head before writing it, but maybe it's just fine, right? And then low is equal to bounds 0. Oops. Right, so we start at 1, right? Delta is equal to... Okay, so then now we want to update low. Lower bound is equal to either the new lower bound or low plus delta, right? Something like this. I don't know. This is just by symmetry and experience, so I don't know if this is right, but something like that. Ooh, I mean the negative one makes sense, but yeah, and then we just max this of 0, and you could early terminate, but I think this is fine, right? Yeah. Honestly, that problem it was all intuition, so I didn't really slow down to prove it, but it makes sense. I'll draw it out later in the explanation. All right, let's see. We have 5 and 6, so I should be able to do it. remove all elements. Choose 2 of the first 3 and then remove them. The cost is the max of, okay, we'll min cost, so the max of the 2 elements. 3 elements win, okay. Fair enough, and you always take the first 3. Oh wait, I misread this. 2 elements of the first 3, and then take the max of the 2 elements. So it makes sense. Greedy would make sense, but, and I'm cheating a little bit. In looking at the acceptance way, it doesn't seem like necessarily too greedy. I have to think of the case, right? So you always leave behind the cheap one as a result. How do you do it? I guess that's why they don't show you any bigger ones, but I guess the idea is that given this 8, in theory, maybe there's a 10 later on, so then you can do it that way, maybe, or something like that, and then remove the 8 without the 8 or something. So there's some weirdness here. N is 1,000, so maybe I should have seen that first. Is it? N is equal to 1,000 is actually interesting, maybe. So it's probably not greedy. Is there a DP? DP, what would that look like? Well, if you only remove, so you only carry 1 element forward, so that's the DP, right? The DP is that you carry 1 element forward because you always eliminate 2. So you have 1 from the pass. Okay, yeah, I think that's fine. 1 from the pass and then the index. So that's going to be n squared, and you have 2 choices, so that's going to be n squared, right? All right. And we can actually something like this, maybe. Right, and then if index is equal to or greater than equal to n, then we return 0. That's fine. And then the case is a little bit awkward. How many numbers do we have left? Well, we always only look at 2 numbers at a time. So we have, okay, a is equal to pass nums of index and nums of index plus 1. We have to be a little bit careful about the index plus 1, right? So okay, so we always have a number from the pass, which means that if index plus 1 is greater than or equal to n, then we just return the max of nums of index and the pass, because we have to pick the max of these things. Actually, I don't, is this case the pass? No. Okay, so this is the case with 2 numbers left. If there's only 1 number left, then it's only the pass, right? So maybe this actually returns the pass, because we always assume that we don't have it. I don't know, we have to be careful. Okay, otherwise, then now we have a couple of choices, right? Let's actually do this. So then pass is equal to, we won't minimize, so let's just go infinity. If a is, so okay, so the only, so we keep the pass. So okay, so we have index plus 2. The pass is going to be either a, right, plus max of BC, right? Yeah, or you have this, you have this, and then you have this. I think that's right-ish. Maybe, I mean, it could be wrong, but 1 and then nums of 0. I mean, it could be wrong by some whatever, but the idea should be mostly okay. Lambda. Oh, I'm dumb, I forgot to. Ooh, infinity. Oh, it's not F max, we want F min. F max is for the score, but F min is for the optimization. Silly Larry. Easy fix though. And 5. YOLO. Not 100% confident about the base cases, but I was just YOLOing. Ooh, and of course I forgot that Leetcode could be a little bit silly. That's okay. Well, I'm glad I didn't do this one, I guess. But it's still very sad. Because this is just n square. I mean, I guess I could have done this thing. I actually should have done this thing, but I just forgot. But let's actually, if we already converted to Java, let's just do it this way. B. It should be an int. There are 1,000. It should be. Oh wait, nums of I is pretty. No. That's still with an int. Where am I using long? This is the one. Integer. Oh, it's because of this thing maybe? I always mess that up actually. Oh, come on. Best is an int. Hopefully that's right. Actually, I should double check some of the stuff. Time limit exceeded, huh? Oh, because it uses this thing. I'm just a little bit lazy today. But also, all of this is like Leetcode's fault. Like, I don't really feel that bad about it per se. Because this is just Leetcode being stupid, if you ask me. Like, that should not have memory limited, and you know. Really? Did I mess this up? It's n square, right? I guess I should have ran it, honestly. No, I mean, this is pretty fast, so I'm actually pretty surprised. And even this is a little bit fast. Let's give a submit on it. That'd be fun if the Python version works, but I don't know. Am I messing this up? Funny enough, the Python version works and the Java doesn't. Why is the Java so slow though? Maybe I'll have to take a look at this. Oh, I mean, use arrays instead of. No, you can't really use arrays because these are integers. You could keep indexes, but I guess I could win it this different way. But it's still, this should not have memory limit exceeded, so I don't know. Anyway, what is my? I mean, I don't know. I got this very. I thought I got this very quickly and should have been with no wrong answers. So that's actually pretty bad. But Q4, a lot of people got. I forgot people cheat. So yeah, okay, never mind that. The leaderboard doesn't matter anymore, especially for virtual. But all right, let's take a look. Given alternate implementation, no adjacent elements are both odd and even. Okay, we've done the cave. Okay. Huh. 590 people got this one. I mean, there are only two things, right? It's just whether there's the odd indexes and the even indexes, and then you just have the first number determines the rest. So then now it's just n n is equal to odd is a little bit. No, that means that even numbers cannot be in the beginning. That's just the same, right? So that means that you have n factorial over n over 2 factorial over or times n over 2 factorial or whatever. Pretty basic, right? And it's just counting. N is equal to 100 anyway, but I mean, the idea is basic. Can we implement it? I don't know. We'll see. Okay, so then now we want to see. And all right, let's focus on the even case first. I mean, maybe it's not that bad, honestly, but yeah. Okay, so if this is even, then we want just n factorial square. So then we want k. The k part is a little bit tricky, isn't it? I mean, it's still a little bit tricky, but because we have to combine two thingies. Okay, so I mean, I guess this doesn't matter then. Then now for I in range of n. Oops. Then now we go. Yeah, I mean, it's just n times n, right? It's so annoying to implement, but I don't think it's that bad. Then it's just count. How do you count precisely? Interleaving, right? So you have n over. Okay, yeah. I mean, right? So then now for I in range of n, maybe one, right? So then here we have some function that's count. I just give it 0 index. I think actually it doesn't matter. And then if not use I, then we want to try it, right? So we do a count, right? We want to count. Okay, yeah. We have to do something. The first number is always a little bit weird, actually. So maybe we'll special case it out because of the odd even parity thing. But it's not so bad. Okay, so then now, I mean, this is never going to be used. So then count. Right. So if I want 2 is equal to 0, then we count where the next number has to be odd, right? So maybe something like. So then this is true. We want to say used of I is equal to true. Maybe this is a maybe, but Not here. I guess we just subtract k, right? So that's fine. Yeah, okay, that makes sense. We just subtract from k directly. Okay, so then now we just have to count. So then now is odd. So then the first number would be I. So then the next number has to be the next number is odd, right? So then we just count the number of odds. I can probably cache this actually. I could probably actually, the way you should do it is probably write this in a cleaner way, but because there are a lot of things going on, but I'm writing in a dumber way just to kind of be a little bit better about it. So then now we can turn because you can these things are only delta on one item, so these are all like basically the same, but I just want to write this is also fine because n is 100. So f count for the function of even odd, right? Even odd. So then we have to do is odd. So then the next number of is odd, right? I don't know how to write infinity in a good way. Maybe because here if we want to write 2, that would be too wrong. Alright. 2, you have two odd and one. So okay, so is that always only to be the case? Maybe not. I don't know. Okay. If now it should return 0 because there's no possibility, right? Okay, that makes more sense actually. And then the next number is going to be odd. All right, so it's just return odd. You can choose any of those odd numbers times f count of not is, oh wait, I guess it should be if it is odd, then we have to return this. That means I need a base case, so I'm going to do it recursively. So now it's even, odd minus 1. And again, I probably didn't need to write this way, but that's fine. Oops. Okay, so then now if even is equal to 0, well, I guess I have to make sure the parity makes sense. So if is, I guess this is the base case. If odd minus 1 is equal to 0 or less than 0, but we need to return 1 somewhere, right? So okay, so I think actually if even is equal to 0 and odd is equal to 0, then we return 1. I think maybe that's the only base case, right? Okay, so then now if current is k1 indexed, they should just make it clear. I don't know why they don't I mean, I guess it's here, but they should just make it clear. It's just so easy to just write one line on it, especially when Leetcode is inconsistent. Okay, so then now if it's greater than or equal to k, then we break and the first to be I, right? Okay, and then now from 1 to n. We want to get the rest of the digits. For I in range of n, if I mod 2 is equal. Wait, why did I write it this way? Oh, because of the count true. What I should write it is here. That's why. That's confusing. Mod 2 is odd. So if this is true, if this number is even, then the next number is odd. Okay, so that's fine. Okay. And then now is not equal to the last number, mod 2. Then we do the same thing, right? So use of I is equal to true, maybe current. Oh, no, that's fine. Oh, I did miss. Otherwise, K. Try current, right? Same idea, actually. Pretty much the same. Oh, I also have to check that it is not used here. We didn't have to do it before because, you know. Oh, brick is brick fine? Brick is fine. Okay. I think this is roughly right, maybe. I didn't handle the impossible case yet. This index out of bounds. Is it I? No. Oh, it's this thing. Maybe that's the case for the impossible case, actually. Length of n is equal to 0, then we just return. Okay, well, that's that's not great, but that's okay. Maybe this implementation as well. Did I mess this up? Why is this way? Okay, copy and paste error, maybe. Okay. What's the answer? I mean, it's wrong, but there's a weird impossible case that I'm not handling here. I was feeling a bit off on this one, but that's fine. Because basically, yeah. No, that changes things. Okay, well, I mean, we didn't even get this one right. So, okay, I mean, I think we're in a good, well, I don't know if we're in a good place, but we're in a place, and that is exciting. Oh, 111, right? 0, it's saying that if we put 0, there's one digit, one number. Is that true? Oh yeah, that is true. But I just did that one. I think we need. So that means that there's too many. Maybe this is strictly greater than. Maybe I'm off by one in some places actually. Okay, let's think about this before. Let's look at this one real quick. So 0, there are two numbers. If it thinks the 0, yeah, this has to be 3 and there's 2, so that's right. 1 is the next number. 1 has 2. Do I subtract? No. I have to print K. That's what I want. Okay, so then we try the 2 and nope, So we want the 1 index of this, of the second number. Yeah, so I mean the first number is right, so maybe it's just in this part and I'm off by 1 somehow, like this part. I'm not quite sure about this actually. If maybe it's this part, because if it's k, then we're going to get 0th element. Maybe that's a little bit more sensible. I mean now it's right, so I guess that was it. Alright, yeah. I mean, or I don't know if it's right, but it is accurate. We just have to convert everything by incrementing by 1. So something like this, and at least it matches the answer. Yes. Whew. I mean, that wasn't that bad, honestly. Well, okay, it still took a while, but I thought I was faster, but maybe not. Maybe that's fine though. Yeah, I mean, I think this one was fine. The only annoying thing is that you know, I mean, clearly Q3 was a little bit annoying just because it was usual Python shenanigans. Like that should not have had 3 answers. And if I didn't have 3 answers, I would have probably made, or 3 wrong answers. What is that? I mean, and this is with cheating. I would have been top 40 or so. So, I don't know, and probably even higher. So this would have been a good contest for me. But yeah, I don't really have much to say because it was very smooth. So yeah, thanks for watching. Check out the videos for explanation. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.